looking at this question here, so it says show that sine x over 1 minus cos x plus 1 minus cos x over sine x is equal to k cosec x. So let's have a think about that. Well, first of all, let's think about what is cosec. Cosec is 1 over sine. So k cosec x, you could rewrite that as k over sine x. So I'm trying to make that left-hand side equal k over sine x or k cosec x. They are the same thing. So my starting point here, I think, is I've got two separate fractions, and I know I need to end up with one complete thing. There's no separate fractions in there. So I think I need to multiply and give them the same denominator so they can be combined into one fraction. So that means that on this side, I need to times everything by sine x. And then on the other fraction, I need to times by 1 minus cos x. So this is, you know, your basic, when you're adding fractions, you've got to have the same denominator. So when we do that, we are going to get sine squared x. I'm just going to write it as one complete fraction because we know it is going to form one complete fraction. That's the point. And then that'll be plus 1 minus, I've written a times there, haven't I? So times by 1 minus cos squared x. Sorry, cos x squared, isn't it even? Don't know what I'm writing there. So 1 minus cos x squared because it's been multiplied by itself. And then that's all over sine x 1 minus cos x. There we go, got there eventually. So I've then got that, and I'm thinking, well, that's not what I want yet. So I'm thinking, let's expand that bracket at the top, because I think I can see I'm going to get some cos squared x's, and then I'm thinking sine squared plus cos squared is 1. So that will help me hopefully eliminate some terms that I want to get rid of. So when I do that, I'm going to still have my sine squared x there. And then I'm going to end up with a 1 and then a minus 2 cos x and then a plus cos squared x on the top. And that is still all over sine x 1 minus cos x. Now, what I wanted, I've got my sine squared x here and my plus cos squared. So that is going to equal 1, isn't it? So I can replace that sine squared and cos squared now with 1. So what that is going to leave me with on the top would be that sine squared plus cos squared is 1. And then plus 1 minus 2 cos x. And then that 1 plus 1, I can just rewrite that as 2, can't I? So that would then be 2 over sine x 1 minus cos x. Now, I'm also seeing here that I could factorize a 2 out of the numerator, couldn't I? So then that becomes 2 lots of 1 minus cos x over sine x 1 minus cos x, and then I'm hoping we can see there that those two things cancel out, leaving me with 2 over sine x. Now, before, right at the very start, I said that I wanted something in the form of k cosec x, which is k over sine x, which I do. So k is 2. So 2 over sine x is 2 cosec x, giving us a k of 2. So that's the first part of the question done. I've proven that that's equal to 2 cos x. So now the second part of the question, it says hence meaning use the thing we just worked out. So explain why that has no real solutions. That means we're not going to get any, if we do get any solutions, they won't be valid solutions. So remember that this whole thing here, we said that is the same thing as 2 cosec x. So what we're really saying is that 2 cosec x is equal to 1.6. That's the thing we are using. If it says hence, use what you did in the previous question, which is why a lot of those questions will be show that's, because you can then obviously still carry on with the next part of the question. So we are saying that for part B, cosec x, let me rewrite that. That's a bit better, isn't it? 2 cosec x is equal to 1.6, which I might actually just write as a fraction because I feel like my brain would be happy with that. So that's 8/5, I believe. And then also going to write that as 2 over sine x because, again, I am more comfortable with working with sine x's. That would make my brain happier. So then I'm not going to make sine x the subject of that equation, so I'm just going to cross multiply those. So that is going to get me 10 is equal to 8 sine x. So therefore 10 over 8 is equal to sine x, or we could say that's the same thing as 5/4. So we end up with this. So we need to think about why would that produce no real solutions? So to think of that, you can type that on your calculator and it's not going to like it. So we need to explain though why that would give us no real solution. So the easiest thing to do is to think, well, what does sine x look like? So sine x looks like this. I remember the y-axis, so f of x is sine x. So remember the y-axis is the values that sine x can take. And it's got a maximum of 1 and a minimum of -1. So we know that sine x is only defined between that range of f of x. So only defined between, and then I'm just going to write that out. So I'm just going to write it here, not 0, it's -1. So between -1 and 1. As 5/4 is outside of that range, outside of the range, sine x equals 5/4 has no real solutions. Hopefully you can read my writing there. So you do need to make a comment. So putting the range is good and sketching the graph, but you do need to justify that. So write in that statement, because sine x is only defined between -1 and 1, we've got a value that's outside that range, so therefore it can't have any real solutions, and that is the answer.